in what we have in this section, as I told you, Shabab, chapter 5 is about trigonometric functions. But before that, this section is not about trigonometric functions. It is about the basics that you need to know before going to the next sections. So what are the angles? What is the angles measure? How to have an angle in the standard position? How to find the length of a circular arc? And how to analyze and study the circular motion, as we will see at the end. First of all, we said that, Shabab, this is a line, this is a segment, this is a ray. If you have two rays, then the angle, as a mathematical object or a geometrical object, it is consists of two rays. One, we call it the initial side, which is the one that you started with. You know the meaning of initial and terminal. You started with, this is initial, and you end with, this is of course terminal. So the angle here is called, of course, this is an angle. And if the direction of the terminal side is clockwise, if it is counterclockwise, we call it positive angle. If it is clockwise, we call it negative angle. If it is this way, the direction of the rotation of the terminal side. And what is the angle measure? What is the measure? How to measure it and what is it? Of course, the measure, the formal definition of the measure of an angle, it is the amount of rotation about the vertex that required to move from R1 to R2. So it is the amount of how far R2 is from R1. Of course, when we fix the vertex between them to be fixed. In other words, it is about how much the angle opens, because this one, it opens a little bit. This one opens much than the previous one. So the measures are different between these two angles. One of the main measures that the Greek people used is degrees measure. And we're still using this, of course, measure until these days. And what they did, they said, if we have an angle that started here, the initial side, then it makes one full rotation. So until the initial side coincide with the terminal side. But now they are, this one is moved until it becomes at the same place of the terminal side. So we did what is called a full rotation. So this is the full rotation. It is here. No need to draw anyone more. So now what they did, they divide Shabab, this circle that we have of the full rotation, they divided into 360 parts. So for example, this part, when you move 1 unit, it is 1 part. So one degree, it is 1 part from 360 degrees. And I told you, this is of course maybe related to the number of the days in a year. So they use this number. No one knows exactly why this number specifically. And you know, when you have 90 units, 90 degrees, when you have 1, 2, 3, 3 until 90, you have the fourth of the rotation. The fourth of the full rotation is this. So this is 90 degrees. If you are here, this is 100 degrees, the half of the rotation. Now, these are different type of angles. This angle here, this is theta, by the way. This is a Greek letter. It is called theta. This angle theta here, it is called what? Do you know? Acute. So this one is called the acute angle. What is the acute angle? It is the angle that its measure is between 0 and 90. This angle is what? Right angle. When the measure of the angle is 90 degrees, it is called right. The last one, the third one, it is called obtuse. What is the obtuse angle? That its measure is between 90 and 180 degrees. The last one, Shabab, it is called straight angle. Look at the funny dialogue here between the right angle and the acute angle. It is just for fun. They mean it is cute, and she said, you are right, what you said is correct. Complementary and supplementary. So usually you focus on this one, not in the second one in this course. So when you have two positive angles and their measure, the sum of their measure is 90 degrees, then they called complementary. If the sum of their measure is 180 degrees, they call it supplementary. What is the complement of 40, ya shabab? The complement of 40 is 50 because their sum will be, and what is the supplement of 40? Is 140 degrees. Now, we said that we have degree measure. Also, there is another measure that is called radian measure. What is the radian measure? And from where? What is the idea of this measure? Let's think, ya shabab, about a circle. Here we have a circle. We have an angle here. This is the angle that we need to measure. This angle here, it is the vertex is at the origin of it is at the center of the circle. You have a circle. This is the center of the circle. The vertex of the angle. This is the initial side, the terminal side, whatever. So the vertex of the angle is at the center. What is the radius of the circle? Is 1, for simplicity, of course, and for the purpose of the measure. Now, what is the angle? What is the measure of the angle? Instead of degrees, we can do what? We can just find the length. What is the length of this side here? This is arc, ya shabab. When you have a circle and you take part from this circle, we call it arc. Arc. Where it is here, arc. Okay. Now, the length of this arc is the measure of this angle in radians, okay? So if a circle of radius 1 is drawn with vertex of an angle at the center, then the measure of this angle in radians, shortly we write it like this, abbreviated like rad, but we don't read it rad, we said radians. And the word radians, in fact, the name radians is coming from where? It comes from radius. It's coming from here, from the radius of the circle. Okay, so it is the length of the arc that is subtends the angle. Subtends here means corresponding to. Now let's take an example here. For example, ya shabab, this is the radius 1. This is the length of this, which is 1 radian. So here, this is the measure of this angle. So this is indeed acute angle. This is, of course, the straight angle. Here we have pi. What is pi here, ya shabab? Pi here is 3.14. You know what is it, approximately. Pi over 2 rad. This is 2 radians. Now, what is the connection between the degrees and the radians? What is the full rotation, ya shabab, in degrees? When you have full rotation in degrees, what is this equals to?
360.
360.
And in radians, what is this equals to? To know what is equals to?
2 pi.
2 pi. Ya shabab, you know that the circumference of the circle, it is 2 pi r, ولا لا? If you have a circle, what is the محيط, the circumference of the circle? It is 2 pi r. بس في حالتنا الار بكم؟ الار ب1. فإذا هاي معناته ان 360 in degrees equals to 2 pi in radians. Okay? And this is the relationship. In fact, this what gives the relationship between degrees and radians. 360 degrees equals to 2 pi radians. If you divide both by 2, you will have 180 degrees or equals to pi. This is what we focus on. Usually we use this one. Why we use it? It is easier to be used, ya shabab. Now, if you want to convert from degrees, what is 1 degree? 1 degree will be what? Divide by 100. Divide by 100. It will be 180 over 180 will give you 1 pi over 180 degrees. So to convert from degrees to radian, just multiply by this. Okay, this is radian. And if you want to convert from degrees to radian, come here, divide by pi. You will have 1 radian. So what is 1 radian? 1 radian equals to 180 over pi. And we have it here, how to convert, of course, from degrees to radian, from radians to degrees, from degrees to radian. To convert from degrees to radian, just multiply by pi over 100. To convert from the radians to degrees, multiply by 180. If you forget this, remember this one, and you will know it. Okay, I want you, ya shabab, to realize how much the difference between these two measures. Let me give you this. Here we have an angle that is theta. Its measure is 1 radian. Who can tell me how much the measure of this angle in degrees. So this one in degrees equals to what? What do you think? Approximately, not exactly.
180 over pi.
180 over pi.
180 over pi degrees. Yes, you are right. It is 180 over pi degrees. What is this? Equals to what? Approximately. This is approximately.
Radian?
Around 60.
Degrees.
60.
Around 60 degrees.
It is 57 point something. Yes, approximately 60. Yes, because this pi, shabab, here it is 3.14, the radian, you know. So it is like 57.3 approximately. Okay. So this is just to have an idea. One radian in degrees means 57.3. Look here at this amazing example. This is, ya shabab, 30 degrees. But look at 30 radians. Because you know that one radian approximately is 57.3 degrees. So here, how many rotations that we, so this is very big, very big angle when it is a radian. طبعا يا شباب, I don't know why this is repeated. I need to erase this. It is repeated. Okay, express 60 degrees in radians. What you will do, you will multiply by what? By pi over 180. So it will be pi over 3. So now you should write now 60 degrees is pi over 3 radian. Okay, even we will remove this. We don't need even to write it. Similarly, pi over 6 is what? Pi over 6, if you want to convert it from radians to degrees, it will be pi over 6 multiplied by 180 over pi. This will be cancelled and this will be 30 degrees. So now again, 30 degrees is equals to pi over 6 in radians and vice versa. This is a very important remark, shabab, like agreement. We need to agree, shabab, about this. When no unit is given, the angle is assumed to be measured in radians. So when we write pi over 3, we mean pi over 3 radian. But usually we don't write the radian. Like this. When I say 10, ya shabab, 3, when I say 3, what I mean here, degrees or radian?
Degree.
No, radian.
Radian.
Radian, ya shabab. Again, read this again. When I say 30, what I mean, degrees or radian?
Radian.
Radian. If I want to mean degrees, I should write this. This is degrees, this is radian. So be careful. Okay? So when you have 10, for example, only, this is radian. Excellent. What you have here, shabab, is the rounded table of angles. Here you have the blue one. The blue ones are the angles in degrees, and the red or the pink one is the angles in radian. Okay, please have a look at this and try to see what they are. The second part of this angle of this section, shabab, is the angles in standard position. When you have angle centered at the origin and the initial side is the positive x-axis, then in this case we say that this angle is in the standard position. All of these angles, shabab, are on the standard position. Look, all of them centered at the origin, all of them have the initial side, the positive x-axis. Okay, now let me give you an example about an angle that is not in the standard position, like this. This one is not in the standard position. Why? This angle. Why it is not in the standard
Can
position?
I answer?
Yes, please, anyone.
Because it is not from the zero, yani.
The
Zero
vertex,
axis.
yes, the vertex of the angle is not at the origin. It is not at 0 and 0. Yes, you're right. Let me give you another example. This angle. This angle here.
Because it's on the
Is it in the
y-axis.
standard position?
No, because it's in the y-axis.
The initial side is not the positive.
Yeah,
Even
yeah.
this one, shabab, even this one. Let me give you another example. Look at this. This one also is not in the standard position. Why? Because the initial side, it is not the positive x-axis. So This is the meaning of the angle. You will hear this word several times in chapter 5 and chapter 6. The angle in standard position. Now, I want you, Shabab, to have a look. Please have a look at the angle in C and A and tell me what you notice.
Rotation.
They have the angle, they don't have the same measure طبعا. The angle here is bigger than this one. مثلا لو كانت هذه يا شباب لو كانت هذه 30 مثلا خلينا نقول 50. لو هذه 50 يا شباب degrees هذه كم؟
410.
راح تكون 410 يعني 50 ضيف عليها 1 full rotation. Yes, you're right. So but they have يا شباب لاحظ معي انه their terminal side they coincide. Coincide I mean they are identical at the end. They match each other at the end. These two angles يا شباب اللي في ال A وال C we call them coterminal. You know يا شباب about this prefix in English co. When you have author, you have co-author. They are having something in common. So they are sharing something. So they are sharing these two angles. They are sharing their terminal, and also the initial as well, of course. For the initial, all the standard position angles are sharing the same initial side, which is the positive x-axis. Now we have here, Shabab, a very important concept that is the coterminal. We said that these two angles are coterminal. So two angles are coterminal if their sides coincide. When they are matching of each other, they are of course overlapping each other. Like this, 60 degrees and 420 degrees. They are of course coterminal. They are sharing the same terminal side. 110, 830. Also they are coterminal. What do you notice, Shabab? What do you notice about 60 and 460 degrees? If you have 60, if you add 360, you will have 420. Similarly, 420, if you subtract 360, you will get 60. Similarly here, Shabab, but here we didn't do one rotation only. We did 2 rotations. So now 110, you need to add 360 twice until you get 830. Similarly, if you subtract 360 twice, you will get that. So what we can conclude from that, ya Shabab, what is the relationship between two angles if they are coterminal? What is the conclusion that we can have? We can say that coterminal angles differ by what? Differ by a multiple of 360. So it is just about adding 360 several times or subtracted several times. Find the angles that they are coterminal with 30. What we will do, we will add 360 degrees. We will add it one time. If you want more, add it twice. And you should know, ya Shabab, from now, what are the multiples of 360? 360, if you add it again, what you will have? 720. If you add it one more, you will have 1080. Mostly, these are the three multiples of 360 that mostly we use. Now, this is if you want positive coterminals. If you want negative coterminals, subtract. If they ask you about negative coterminals. Similarly, Shabab, if the angle is in radians. If the angle is in radians, if you want to find the coterminal, what you will do? You will add 2 pi, because the full rotation in radian is 2 pi. You can add it one time, then 2 times. Here, indeed, this is 2 pi plus 2 pi. So if you add 3 pi, it will not be if you add only 3 pi, this is not coterminal. This is wrong. Because we adding, ya Shabab, 2 pi one time, 2 times, 3 times. So when we add here, we add 2 pi, 4 pi, 6 pi, and so on. The multiples of 2 pi. I will mention this in general in the next slide. So now this is, of course, you will simplify just here, it will be 7. So this one and this one are coterminal. This angle and this angle are coterminal. If you want negative angle, subtract. So this angle, its coterminal angle is this, by over 3. In general, ya Shabab, we have this. all the coterminal angles with theta degrees are what? Theta degrees plus 360 n. What is n? N is an integer. So n here could be 1, could be 2, could be -1, could be -2, and so on. So it is about theta degrees plus or minus 360 several times. But no need to write the negative, it is included in n because n could be positive, could be negative. If it is in radian, just add 2 by n. So which means 2 by 1, 2 by 2, 2 by 3, and so on. Let's take an example about a little bit big angle. So here he wants to find an angle with measure between 0 and 360. Usually this is what we will do. We will look always, ya shabab, for the least positive angle, the smallest positive angle that is coterminal. And this one will be between 360, which means that it is without any additional rotation. It will be in the first quadrant, not another rotation. So now how to find the angle, the smallest positive angle that is coterminal with this one? Who can tell me what we will do? We will subtract, ya shabab, what? We will subtract 360. What do you think? How many times?
3 times.
3 times. You remember the multiples of the multiples of 360?
1080.
360. These are the multiples of 360. So I think here it is practical to subtract 180 degrees 3 times. So we will get 0, 1, and 2. Is this between 0 and 360? Yes.
Yes, it
This
is.
is what we are looking for. طبعا if you subtract only this one, if you subtract, you will not get an angle between 0 and 360. طيب يا شباب, this is not difficult طبعا when you have 1200. What about if he said 12,900? How to do that? Are you going to subtract 360 and then time and time? No. There is a better
Divided
way.
by 360.
Who said that?
Ahmed.
Ahsanti Ahmed, you are totally right. So the idea, ya shabab, is if you have an angle that is big, divided by 360, look what you will have here. What you have here will this tells you how many times you need to subtract. And don't worry, the remainder here is the coterminal. And this is the same answer that we obtained. Okay, good idea. Now, these are, ya shabab, examples about the coterminal angle with 60 degrees. And I will leave it for you to have an idea about it. And I want you, ya shabab, now to solve this, please. Take a pen and paper and start solving this old exam question. For sure, ya shabab, you will be asked about the coterminal. Now, try to solve this, ya shabab, in 2 minutes. I will give you now, I launch a polling for you here. You can fill this poll. Solve it and then choose the right answer. The question is about which one of the following angles is coterminal with 50 degrees, which means that four of them are not coterminal. Only one of them is coterminal. How to know, ya shabab? In this kind of problems, you can solve it by 2 methods. One, to start with 50 or to go to the choices. But I advise you to work on 50 itself. So what you will do, you will look at 50 and you will add 360 as many as you need and subtract it as many as you need until you get an answer. This is the idea. And mashallah, I have noticed that most of you, they obtained the right answer now. We have 9 students answered so far. Okay, what about the others? We still have 8 students. They don't know what is the answer. I think this is enough, ya shabab. Let me end the polling and show you the results. Most of you went with the third choice, and this is the right one. Great. Let me show you how, for those who didn't get the right answer. So you have 50, you will start with 50 degrees, you will add 360, and you will look what you will have. What you will have here, 401, 410 degrees. It is not in there, so we need to add it again. What we will have if we had it, we will have 770. Is it in the choices? No. Now, if I add, ya shabab, 130, if I add 360 again, I will get 1,000 points, 1,000 something. I don't have this in the choices. So no need, stop here. So you will stop just here, 770. So no need to add more. Now we have negative angles. So this means that this is not an answer, this is not an answer. The answer maybe it is C, D, or E. So what you will do, you will take 50 degrees, you will subtract 360 degrees, and this will give you what? This will give you negative angle, of course, which will be negative 310. Is it in the choices? No. And of course, you will subtract again 360. What you will have? If you subtract it again, you will have a negative angle, which will be here, the sum of them, which is 670 degrees. Is it in the choices? Yes, it is. Here it is. That's it. So these are, of course, this is the angle that is coterminal with this angle. Now let's continue, Shabab. You know about when you have the XY plane, we have 4 quadrants. Now we want to talk about the angles. An angle in standard position is said to lie in the quadrant in which the terminal side lies. For example, this one, this angle, we will say that this angle is in quadrant number 1. Why? Because its terminal side is in the first quadrant, because it is here. If it was in the second, like this one, if the terminal side is in the second, we will say that this angle is in the second quadrant. Now, this is, ya shabab, the angle 0, when you have nothing. Then if you make a full rotation, you will have 360 again. So they are the same. They are identically the same, but of course with one full rotation. This is 90 degrees, 180 degrees, 270. So if your angle in the first quadrant, then it is between 0 and 90. So this is the same. If I say it between 0 and 90 degrees, I mean in the first quadrant, and vice versa. It is in the second if it is between 90 and 180 degrees. In the third, if it is between 180 and 270. And of course, in the fourth, if it is between 270 and 50. What about 90, ya shabab, and 180 and 270? For example, 90, is it in the first or in the second quadrant, ya shabab?
First.
No.
The y-axis.
Any angle, ya shabab, any angle on the x-axis or the y-axis, it is not in the first, it is in the second, it is not. It is at the border between them. So angles in the standard position whose terminal side lies on the x-axis or the y-axis, like these angles, are not in any quadrant. They are called quadrantal angles. So they are on the border. The third part of this section is about how to find the length of arc. So this is a circle. This is arc. Arc, it is part from a circle. How to find its length? The idea comes from the radian. Do you remember, Shabab, the radian? How we define the radian? We said if this is 1, this is theta, then this is theta also. So the angle, the measure is the same. Now, if the radius is r, not 1, this is called s. And what will be s? S will be r times theta, or theta times r. So when you multiply these two, they will give you s. And this is so easy, Shabab. A very good idea for you to remember S equals to R theta. So if you forget, just draw this. This is S, this is theta, this is R. So S equals to R theta. Okay. So what is this? In a circle with radius R, the length S of an arc that subtends a central angle theta corresponds to, it is S equals to R theta. What is important here, ya shabab, is this. It is in radian. Here, when we have this relationship, of course, we are talking about radians, not degrees. Okay. So if you want r, divide by theta. If you want theta, divide by r. So clear. Now let's take an example. Find the length of arc. So what he wants s. Find the length of arc of a circle with radius 10. So we have r equals to 10. 10 what? 10 meter. Be careful about the units. That subtends a central angle of 30 degrees. So theta is 30 degrees. So according to the relation here, what is s? S equals to r theta. Is that right? Then what is r? R is 10 times theta is 30. So what we have? 360. What is the units? Meter. So the length of the arc is 300 meter. Is that right?
No. No.
You said no. Why it is not correct?
Because degrees.
Because this is in degrees. Yes, we said whenever we use this relationship, theta must be in radians. So we must first convert this angle to degrees. What is from degrees to radian? What is this in radian, Shabab? It is pi over 6. So this one here, it is pi over 6. And this means that we will have 5 pi over 3 if you simplify. And of course, pi here is 3.14 approximately. Great, ya shabab. So here we are. Now, in the second part, we have theta, an angle theta in a circle with radius 4. So we have r equals to 4 meter. Subtends by an arc of length s. We have s equals to 6 meter. The units are the same. This is good. Find the measure of theta. What is theta? What is theta, shabab? Because s equals to r theta, theta will be s over r. And this is so easy. It is 3 over 2 radian. A caution, this is a very important caution, shabab. When the formula s equals to r theta is applied, the value of theta must be in radian, not degrees. The last part of this section is about, shabab, is about the circular motion. What is the you know what is the motion? The movement when you move. When you move on a straight line or on the street, this is a linear motion. But when you are moving on a circle, this is a circular motion. طبعا here you know we have speed when we are moving in a straight line, shabab, we call the speed here the linear speed. It is so easy, so clear. For example, if you have a particle or someone or a person that was here, but after some time he becomes there. So now we have a distance here. The distance that he traveled now from this point to this point, it is called the distance, of course. And you know, Shabab, that the speed, the usual speed, it is the distance over the time. This is not new for you. Now, when we have a linear motion, we have only one speed, one velocity. So the measure of how fast the position B is changing with time is called linear speed. But let's say that this person becomes here after some time. He becomes here. Okay. Now, of course, the distance has been changed, and of course, how fast the position changed, we can measure it by dividing s by time. But there is something also changed, Shabab. What is it? What is also has been changed here? When we are on a circle, the angle that is corresponding to. So here it was theta. This is another angle now. Look, theta is different now from one. So when you are moving on a circle, the theta, when you are from here to here, the theta will not be the same when you are from here to here. So also theta is changing with time. So this, because of that, theta, the ratio between theta and the time, theta is changing with time. So we have another speed. They call it
Omega.
the angular speed. Yes. Please, what you say? So we have another speed that is called the shabab, the angular speed, and we use the Greek letter omega. This one we usually the Greek letter nu or v, you can call it v, no problem. So the measure of how fast the angle is changing is called the angular speed. In short, if you have s equals to r theta, then of course the linear speed will be s over t, which is the distance over the time, and the angular speed is the angle over the time. Okay? طبعا don't forget يا شباب that theta is in radians. Don't forget that always here when we deal with that. Omega is the Greek letter, and also this is nu. You can call it like that. It is called nu. It is in Greek, but you can say v, no problem. So now the units of the linear speeds are the usual units: meter per time, مثلا, meter per second. What is the units of the angular speed يا شباب? Theta is in radian. Radian per what? Per time. مثلا radian per second. So the units of the omega is radians per time. Now, what is S يا شباب? S is what? R theta over T. Is that right? So the linear speed equals to R theta over T. Now, what is theta over T?
Omega.
So we can write that V equals to R omega. And this is the relationship, the interesting relationship between the linear speed and the angular speed. So how to recall that? The linear speed equals to the radius times the angular speed. Let's take an example. We have a boy here that he is rotating a stone in a 3 feet long sling at, let's start one by one. When you have, let's say this is the boy and this is the sling, this is the rope that he has, okay? Now he's starting rotating this rope in a circular way, like this. Now this rope, the length of this rope is 3 feet. So what it will be for the circle? This rope, the length of this rope, what is it for the circle?
Radius.
The radius. So here we have R equals to 3 feet. This is what we have. Look at here. Look, it is here. If you rotate it, it will be like this. Excellent. So until here we are okay. So at the rate of 15 revolution. Revolution, revolutions means rotation. When you revolve something, you are rotating that thing. So we have here 15 revolution every 10 seconds. Every 10 seconds. What is this? The question is find the angular and the linear velocities. By the way, velocity or speed, you know that the speed is the absolute value of the velocity, but in the case of the circular motion, they are identical to each other. So the velocity or the speed are the same, because here we are not, of course, interested in the direction in this kind of motion. Now, this is not the angular speed, but if you did one small thing, it will become the angular speed. So if you did this 15 over 10, when we have one revolution, one revolution. How many bias in how many radians in one? 2 by radian. So when you have one revolution, remove this one revolution, write instead of revolution 2 by radian. No need even to write radian, by the way, but we keep it just for something. And here we have seconds. So what I did, I just one revolution, instead of revolution, I write 2 by radian. Now, what is the speed that its unit is radian per second, radian per time? Remember, I told you in the previous slide, here, omega is radian per time. So here we have the omega. So this is omega, Shabab. So omega here is 2, this is 1, this is 5, 15 over 5 is 3. So it is 3 by radian per second. So we did find the angular speed. He wants also the linear speed. So the linear speed will be R times omega. What is R? R is 3 and omega is 3 by. So this will be 9 by. Omega, V you know what is the unit of the linear speed, distance per time. So the time is second, the same unit, and here this is feet. When we have the units of the length, no need to write rad. Khalas, rad is gone, because we have agreed that 3 pi, you can write it 3 pi without rad or with rad. But when we have the units of the length, khalas, no need to write rad. So this is, ya shabab, the best way to solve this. طبعا this is solution number 1. I put it here for you because I believe that it is an interesting one. It is not mentioned in your book, by the way, but there is another way to solve it according to your book. Don't forget, ya shabab, these relationships that we have. These are the 5 identities that you will use, or formulas. This is what we did exactly. Omega is just, I replaced 1 revolution by 2 pi radian, and then I obtained omega. Then I multiply by r, obtained nu. The another solution depends on these formulas, how to find v from here and omega from here. So you need to find theta at the beginning, and just theta we obtain it by multiplying. This is theta, 2 pi multiplied by 15. This is the theta that he is talking about. Then he used theta over t. Then he find s, which is r theta. Then he divide s by t to find the nu. But again, this was easier, the solution number 1. Let's now take another example. I think it is important. I mentioned this before. A man is riding a bicycle whose wheels are 26 inch. This is inch, by the way, in diameter. What we can understand, what we can obtain from here, Shabab? What is that?
The radius is 13.
The radius is 13 inch. The radius is the half of the diameter. You are right. If the wheels rotate at 125, so we have 125 revolution per minute. So this is not omega, Shabab. But if you convert the revolutions into 2 pi into radians, now it is the omega. So this is omega now. So we have omega, we have r. This is 124 revolutions per minute. Shortly, ya shabab, this revolution per minute, look how they write it, RPM. And this is what we have in our cars, the RPM that we mean. It means about, of course, how many revolutions per minute your tire is doing. Find the speed in mile per hour. This is about the units, ya shabab. You need to convert the minutes to hours, and the feet or the inches to miles. Usually we don't use these units, ya shabab. In our book, in our measuring system, we don't use these. We use meter, kilometer, and so on. So just I want you to have an idea about these measures. So we have, as I said, ya shabab, we have omega, we multiply it by r to have nu. So here we are. Now this is the result in inch per minute. Inch per minute. He wants this to be mile per hour. For this, ya shabab, inch per minute, you know how to convert to hours. Let me just focus on this part. How to convert from minute to hours? You will remove this 1 minute. 1 minute equals to what? 1 over 60 hours. Is that right? So just I will write here 1 over 60. So this is why it will become in the denominator. Now for inch, how many miles per inch? So you need to ask yourself, 1 mile equals what? Inch. Indeed, you need to just to let you have an idea. 1 mile, shabab, is 5,280 feet, and 1 foot equals to what? This is just for your kind information, because you will be an engineer. So how can you miss these? It is 12 inches, and it is different from country to country. By the way, these miles, these measures are not fixed. But I'm talking here about the US measurement. I put it here for you just for your kind information, or maybe you have some homeworks or homework problems about this kind of measures. But usually, what we will ask you about, we will give you in meter, kilometer, and so on. Like this example, I will give you an exercise about that. Now, to summarize, shabab, this is what we have. This is the summary of this section. What you need to know, how to convert the standard position, the coterminal. The most important part of this section is the coterminal that we will use in 5.2, 5.3. And of course, this relationship between the linear speed, angular speed, the length, arc length, and so on. Now I want you, Shabab, in 3 minutes, 2 to 3 minutes, to give me an answer for this question, which is easy, by the way. Please, let me launch polling for you. Please, ya Shabab, try to solve this. If you forget the relationship, I can write them for you here. Let me write this here for you. What we have S equals to R theta. We have nu equals to S over T. We have, what else? Omega equals to theta over T. We have also nu equals to R omega. I think these are the most important ones that we are using. MashaAllah, there are some students, they already finished. MashaAllah. Keep working, Ishmael. Be careful about the units here, by the way. There is a trick in units. The units are not the same. If the wheels of a car with a radius 0.25 meters, so here R is equals to 0.25 meter, which is, by the way, 25 over 100. You can keep it as it is, or you can write it as 1 over 4 meter, as it is, as the problem will tell you what to do. So this is R. Are rotating at 600 revolutions per minute. So this is not omega, by the way. But then what is the linear speed? The question is, what is the linear speed? What is V? What is nu? Yalla Shabab, I give you a hint now. Only 6 students answered so far. 6 students, but only 2 of them got the right answer. 7, only 2 of them got the right answer. Check your answer again, Shabab. For those who choose C, الشباب اللي اختاروا C, المستعجلين, it is not right. It is not correct. C is not the right answer. I have noticed that 3 students choose C. It is not the right answer. So this is another hint. Ya Shabab, take a pen and paper, start practice, please. So now what is this? From here you can obtain omega. Omega will be equals to 600. 1 revolution means 2 pi radians over minutes per minute. So this is omega. Now what we want mu, we want the linear speed. It is r times omega. You have r is 1 over 4 times omega. What is omega? This is, by the way, you can simplify it to be 1200 pi radian per minute. So this is equals to what? 1200 pi radian per minute. Not radian here because this is a linear speed. So the units will be, of course, the length units. What is the length units? Meter per second. We have here meter, so it is the same units. The problem here that we have minutes per minute, but here he wanted per second. So we want this to be seconds, not minutes. What is the relationship between the minutes and the seconds? 1 minute equals to 60 seconds. 1 second equals to 1 over 60 minutes. You know how to convert, of course, between these units. Now I think the idea, Shabab, is clear. Let me end the polling and show you the results. 5 students with the right answer. The right answer is A. Good. But we still have some students with B, C, and E. Now, Shabab, you need just to convert this. So it will be what? 1 over 4 times 1200 by, don't forget by, meter per 1 minute. I will just remove minute and write instead of it 60 seconds. Now this will be, of course, 60 over itself is 1. This will be gone, and this will be over 6. It will be 20. 20 over 4, it will be 5. So we have 5 by meter per second. So the right answer is A. If it was the opposite, Shabab, suppose that it was the opposite. Let's suppose that in the next slide. Suppose he said this per second, instead of this, if we have this in seconds, and this one he wanted it to be in minutes, what will be the difference? In that case, you have V equals to R omega, which will be, as we said, 1 over 4 times 1200 by. Here, if this will be, of course, meter per second. How to convert it to minutes? It will be 1 over 4, 1200 pi, meter, and instead of 1 second, we will write 1 over 60 minutes. Okay, so this 60 will be in the denominator. So it will be 1 over 4 times 1200 by times 60 minute per meter per minute. Is that clear, Shabab? Okay. طبعا there are here many solved exercises for you, Shabab, to practice. I will leave them for you. Most of them are basic. Here we have an example about an interesting example. I should mention it. Not this one. I will leave it for you. This is not difficult. There is an idea here that we should mention here, not here. How many degrees? No, this one. I have one. I think you will have it in the recitation. It is not here. So you have a question like that in the recitation. These are very important exercise. In the recitation, there is a nice trick. Yes, I heard someone wanted to say something. Okay, let me mention this, Shabab, in the slide, in the recitation, the idea of a question, not this one. And you will solve these together, inshallah, with your recitation instructor. This one. Yes, I think this one. This is the trick here is very important. You should focus on that. And here you have some old exam questions. I will skip them and leave them for you. Let me go back because I think we have a solved. For this recitation exercise, you have an example here. So this example. where it is. This one, no. The one with two, this one. Now, Shabab, when you have something like this, let me give you an idea about how to solve this one. Now, here you have two gears adjusted so that the smaller one drives the bigger one. If the smaller one rotates through an angle with theta here. So here what we have here, R1, the smaller one is 2.5. R2 is equal to 4.8. Now also here, this theta, it is in degrees, by the way. You should convert it to radians. So theta here is in degrees. This is theta for the smaller one. So it is for one. It is 220, 150 degrees. What is this in radians, Shabab, if you convert it? It is 5 pi over 4. 5 pi over 4. Okay. Now, what is the question? Through how many degrees? The question is, what is theta? What is theta 2? In degrees also. What is this in degrees? Okay. How to do that, Isra? This is a very important trick.
Divide by 180 and multiply by pi.
Yeah, Shabab, the concept is what? When you have, like you have, assume that you have a car with two tires. One is smaller, one is bigger. What will be the difference? The difference will be omega. Omega will not be the same because the rotation, the amount of rotation will be different from the smaller. But the speed, ya Shabab, the speed will be the same. Is that right? The linear speed. The linear speed will not be changed if you have smaller or bigger. And also the distance traveled. If you traveled with a car from here to Dammam, it will be the same, of course, because you will arrive at the same time with the same distance. So here we have S1 equals to S2. This is the trick. And this means that R1 theta 1 equals to R2 theta 2, because you know that S is R theta. Now you have this, you have this, you have this, you have this. So now just you need to find what is theta 2. Theta 2 will be equals to R1 theta 1 over R2. The detailed solution is here, Shabab. And you have a similar question in the recitation and also in the old exam questions. I'll stop here. We have finished for 5.1. If you have any questions, Shabab.